Hello guys, so today I'm going to be doing a demonstration on implementation of role-based access control. So role-based access control is a type of access control mechanism that is used together with authorization, to make sure that the system is secure, to make sure that a user doesn't have the access to do what they are not supposed to do. So before I get into that demonstration, I have like some things I would like to talk about. Let me get into full screen mode. So I have some things I would like to talk about, and I'm going to get to the notes. Yes, so I am going to do a demonstration of role-based access control in Linux. I'm actually in my Kali Linux environment. So before that, I would like to talk about a security model called IAAA security model. I would like to talk about this security model because this security model is also referred to as the four pillars of InfoSec or information security. The I stands for identification, the A stands for authentication, the next A stands for authorization, the last A stands for accountability, and these four pillars actually work together. Just imagine you have a house and you have a house and you have like four pillars holding this house. If one of the pillars should get compromised, the structure or the structural integrity of the house is going to be shaky. If another pillar gets compromised, the house itself will barely be on, like it will barely be standing. So you need these four pillars to work together, as they are rightfully called pillars. You need the four of them to make sure that the system is secure. You need the four of them to make sure that the confidentiality, the integrity, and the availability of a network, of a system, of an organization is ensured. So what is identification? Identification has to do with assuming or claiming an identity, saying that you're this or saying that you're that. That's identification. It's actually verifying one's identity or verifying a user's identity. That's verification. And normally verification always starts with assuming an identity, assuming or claiming a specific identity. And the next pillar we're going to talk about is authentication. So now after you've claimed that, okay, I am Johnson, or my email is johnson@gmail.com, or my username is Johnson 406 at gmail.com. The next step is to authenticate, is to verify, is to confirm rather. Is to confirm that, okay, you say your name is Johnson, or your username is Johnson 406, or your username is Johnson at gmail.com. Now we need to confirm that indeed this is your identity. We need to confirm that, for sure this is your identity. You're not falsifying or claiming someone else's identity. So the way we ensure the authentication is by using one or more of these what do I even call them, one or more of these concepts, or of this mechanism, or this system. So we have authenticating by something, authenticating by something you have, or authenticating by something you are. So now let's say a user tries to log into his account and he starts with identification. He assumes an identity. He says he's Johnson at gmail.com. So the system is going to ask for his password or biometrics. So where the system actually asks for password, it means that this person claiming to be Johnson at gmail.com has to authenticate using something he knows, which is password. If you say you're Johnson at gmail.com, you should actually know Johnson's at gmail.com password, so you can authenticate with something you know, like in systems where two-factor or multi-factor authentication is enabled. You can actually authenticate with something, for instance, your password, your PIN, and you also have to authenticate with probably something you have, your mobile phone, because an OTP code might be sent to your phone, and you have to use OTP code to authenticate. So in systems where they have actually implemented defense in depth, we can actually have two-factor, multi-factor authentication in place. So that's authentication. Authentication is confirming the identity of a user or a person or a system or a process. Yes, that's authentication. So after a user has been successfully authenticated, after the user has claimed an identity, by providing by providing a username or an email, you want to move to authentication. This is where the user gets to confirm that they are indeed who they say they are. So they can confirm this by using something they know, something they are. Something they are is like using biometrics, fingerprints, retina scanner, stuff like that, or something they have using your key card, using your phone to receive OTPs and stuff. So after you've done identification, you've authenticated, the next step is actually authorization. Before I continue, just hold on. So authorization, which is the third pillar, actually refers to giving an authenticated user the right level of access or the right level of privilege after they've been successfully authenticated. So let me give an example. Okay, before I get to the example, I say that authorization is giving an authenticated user the right level of access or the right level of privilege or the right level of permission to like a resource, to a data, after they've been successfully authenticated. So how can we ensure authorization? We can ensure authorization by using access control mechanism, and which I'm going to be doing a demonstration on one. I said I'm going to be doing a demonstration on role-based access control. So after a user has been authenticated, then they've been authorized. How do you ensure that this authorization is not abused, or how do you ensure that this authorization is not misused? That's where we bring in access control mechanism. Access control mechanism helps us to ensure that a user does not do anything outside the permissions or the privileges that have been given to them, into the authorized account or the authorized environment. For instance, someone books a hotel, you give them their key card, and with the key card they can actually authenticate through the door, and get into the room, which is the authorization. Now they have access to the room, they can use the bed, they can use the bathroom, so but what stops them from trying to get into somebody else's room? So you want to make sure that the key card you're giving to them, or the keys you're giving to them when they book the room, you want to make sure that these keys or this key card cannot open any other room except their own room. That's the only place that key card should be able to authenticate and authorize them to use that very room. Another thing you might want to do in form of a control is to have like a surveillance camera or a CCTV camera in place. You can see a hotel guest trying to brute force their way into somebody else's room, and you can call in the security on them. So these are like non-technical examples of access control, but a more technical example of access control would be okay, let me use a very, very good example. So let's say in a building or in a military facility, you know, we have a room that is labeled top secret, or a room that is labeled confidential. You want to make sure that not just everybody, or not just any military personnel should be able to access that room. Even if their key cards can be able to clear them from the main entrance into the building, their key cards, just any key card, should not be able to like clear them into the top secret room or into the confidential room. You want to make sure that that very room is only for people with higher level of access or higher level of security clearance. So that's how you ensure authorization. You ensure authorization by using access control mechanism, you know, and so pardon me. And when we're talking about access control mechanisms in cybersecurity, we actually have three main type of access control mechanism. We have the discretionary access control, we have the role-based access control, and we have the mandatory access control. The discretionary access control is when the user of a data or of a resource explicitly defines who access or who doesn't access their resource. A non-technical example would be, you have like bunch of keys. Let's say you have 5 keys that can open your main door, and you decide that you want to allocate some of these keys to some of your friends, so that they can access your house when you're at home or when you're not at home. That's an example. That's a non-technical example of discretionary access control. And a technical example would be, you have your laptop and you choose to share the password to your laptop with some of your family members, so they can use the system while you're not around. So role-based access control is a type of access control where users actually have access to a data or resource based on their role. For example, you have a directory that is labeled finance. So you want to make sure that only the finance department, like only staffs or personnel in finance department, should be able to access that directory, because it actually contains accounting and finance related files. So the way you want to do it is, you want to create a group, add all the finance personnel there, and make sure that this group actually has read, write, and execute access to the finance directory. So somebody who is in, let's say somebody who works in marketing, will not be able to access that directory because they are not in the finance group. So that's role-based access control. Role-based access control is giving access to a system or a resource based on a user's role. Then lastly, mandatory access control. Mandatory access control is an access control that has been defined, or that has been predefined into the security policy of a system. Let me give an example. So in role-based access control, okay, let me leave that. So let's assume we have a military building, and then there is a room where like all the generals usually have meeting. If you're a general, you should be able to access that room. It's more like role-based access control, based on someone's role or someone or the function of a user. So you have this room, and it's where the generals always have their meeting. Mandatory access control would be like, let's say for you to get into this room, you need to swipe like your key card as a general, then you get access to this room. Mandatory access control would be predefining some rules into the machine where the general swipe their card. You want to predefine some rules that only General A, General B, or General C should be able to have access to this room. So if you come there, irrespective of the fact that you're a general and you swipe your card, you may not have access to the room if it has not been explicitly defined into the security policy of that device, that you should have access, then you'll not be able to have access to that room. So that's an example of mandatory access control. This kind of access control is usually implemented by a systems administrator, for example. So I actually highlighted this number 3 differently, but in the course of explaining the IAAA security model, I've also talked about the two of them. I've talked about authorization and I've talked about access control. They always go hand in hand. And before I move on to my demonstration, I also like to talk about the last A, which stands for accountability. So after a user have been authorized to use a system, or authorized to use a space, or authorized to get into a room, you want to make sure that the action of that user is being recorded. Whatever they do is being logged, so you can have like a history of that user activity. So that's accountability for you. So you can be able to hold users accountable for their actions, or you'll be able to investigate what system didn't do what. So that's accountability. So how do you ensure accountability? You ensure accountability by using a login system. A login system is similar to your call log, where you can actually go back and look at all the missed calls and all the sent calls or dialed numbers, or all the received calls. It's something like that. But now you can actually see when a user authenticated, you can see when they logged off, you can see what they delete. So you want to have like a login system to ensure accountability. And in information security, we often use something we call SIM. It stands for Security Information and Event Management. We often use SIM tools to ensure accountability. So what SIM tools do is that most time they are often like a centralized service, like a cloud-based service that collects data from various systems, or various applications on its systems, and kind of aggregate them together, like make a summary of what's happening on that system. So you can easily, like a security personnel can easily go through this summary, or go through this aggregation to see what exactly is happening in the system in terms of security at a glance. So that's how we ensure accountability, by using login system. So I'm going to get into my demonstration for today, which is implementing rule-based access control mechanism, or implementing role-based access control. Okay, so you must be wondering that, okay, why did you choose to do this demonstration instead? Why did you choose to use role-based access control? I chose to use role-based access control because I feel like in most work environments, this is what is used, because it's very easy to manage. If someone who was working in the finance department gets transferred to like a different department, let's say marketing, all I have to do is remove the user from the finance group that gave him access to the finance directory. For example, is just to deprovision the user from that group and add the user to the marketing group, so that person can also have access to all the marketing files. So it's very straightforward, it's very easy to manage users. So that's why I chose to do a demonstration of role-based access control. So I'm going to clear up my screen, and then I'll walk you through the steps. So okay, let me go back to my notes. Oh, I spelled the notes wrongly. Okay, so this is my notes. So I'm going to walk you through the steps. So step one, for this my demonstration, step one is going to be create 4 users. Step 2 would be create the required group. Step 3 would be add users to the group. Step 4 would be add users to the group, change group ownership. Step 5, change group ownership, change ownership, change group ownership. So step 5 would be adjust directory permission. So this is how it's going to be. I'm going to create 4 users now. So the way it's going to be is that for me to demonstrate this role-based access, like how to implement role-based access control on a very simple but very useful way is, so I'm going to create a directory. I'm going to assume that I work in an organization, let's say like a bank. So I'm going to create a directory, and that directory is going to be called mobile app. So let's assume that this bank is trying to build their mobile app, so they are going to need like a team to work on this mobile app. So I'm going to create a directory called mobile app, and we're going to assume that in this directory we have all the important files required for this project. So I'm going to create a group, and in that group we are going to have a developer, we are going to have let's say a cybersecurity professional or a personnel. Then we're going to have like a project manager. So if you notice, I said 4 users. The 4th user is going to I'm going to call the 4th user OT. That's what I'm going to call it. OT for short stands for others. So the 4th user is going to represent every other person that is not these 3 persons I mentioned, that is not a developer, the security personnel, or the project manager. So we want to make sure that we add these 3 users to our group. We're going to create a group, and we're going to call it dev team. That's what we're going to call that group. We add these 3 users to that group, and these 3 users, or the dev team as a group, can actually have ownership of this directory. We can also like set their access to this directory, what they can do to this directory or in this directory. So the 4th user OT just represent others. We want to make sure that others cannot have access to this directory, or we want to make sure that others can have access to the directory, but they cannot write to the content of this directory. It means they cannot modify the contents, they cannot add to the contents, and they cannot delete from this directory. So that's how this project is going to be. So I'm going to start by creating a directory called mobile app. Save this out. Make directory, put it in my desktop. So I'm going to call it mobile app. Make sure it's there. So mobile app is there. So step 1, what is step 1? Step 1 is create 4 users. So I'm going to create, so for the cybersecurity personnel, I'm going to call that user cybersec. For the project manager, I will just call the project manager pro. For the developer, I will just call that user dev. That's how it's going to be, just to make everything simple and quite comprehensive. So add user, mm, user add, um everything being lowercase, cybersec. So this user actually represents the security personnel. So if you notice, I actually use the flag M because the flag M creates this user and also creates a workspace for this user. Like this user is going to have its own home, it's going to have its own like its own home directory. I don't know if you understand what I mean, like its own workspace. We have the home directory and we have like a user's home directory, so it's going to have its own home directory. That's what I'm trying to explain. Okay, so I need elevated privilege to be able to carry out this task. Let me see if this worked. All right, okay, it worked. So I'll move on to creating the next user. Sudo user add. See, is the project manager. Move on to the developer dev. So yeah, so we have the last person is going to be OT. Sudo user add OT. Okay, so we can also, okay, it's fine, let's leave it like this. So the next thing now we are going to do is create the required group. So we are going to call this group dev team, and the way you create a group is group add dev team sudo group add dev team. So how do I know this group has been created? Yep, the group has been created. So let me clear this up. So now we've created a group and we have to add the required users to the intended users, like people who are going to be working on this mobile app project. We need to add them to a particular group, which is the dev team group, because we want only this group to be able to access this directory. Obviously I'll be able to access the directory because I created the directory as cybercat. So cybercat owns this directory. The group that owns this directory at the moment is also cybercat, my default directory, which I'll have to change ownership, but I will not be changing ownership for like the user called cybercat, just because this is a demonstration. If maybe my job was just to create this directory and hand it over to, let's assume I have like a supervisor that is going to oversee the project, or the cybersecurity personnel that is part of the project is going to be the one overseeing the project, and I'm not supposed to have access to it. After now, what I'll do is I'll transfer ownership to cybersec. In this case is the security personnel in this dev team project. I will transfer ownership to the person, but I'm not going to do that. My demonstration is only going to show access control for every other user that is not dev team. That's just it. So desktop So this is it. This is mobile app. As you can see, the owner of this directory is CyberCat. The group that owns it is also CyberCat, you know, and both the group and the owner of this directory actually have full access, read, write, execute, but others can only read and execute. Read means that execute means that they can cd into that directory, and read means they can ls, but they can't add, delete or modify from this directory. So what I want to do now is add dev, add cybersec and pro, like these three users. I want to add them into this group called dev team that I created. So I'm going to say user mode, add to group. The name of the group is dev team. The name of the user is dev. Let me see if I can do three at the same time, if this is going to work. Okay, it didn't work. So user mode, append to group, group name dev team pro, sudo user mode, append to group name dev team user pro. So think dev team cybersec. So I didn't want to use sudo the second time, because if you use sudo like twice, it's going to stop asking you to use sudo, to carry out like a task that required elevated privilege. So but I don't know why it's still asking, so I'm just going to go ahead and use sudo dev team cybersec. What did I miss? Oh, bad. Sudo user mode, append to group cybersec, sudo user mode, append to group dev team. So we've added cybersec, we've added pro, and last one is dev. Good. So how do I know if these users have been added successfully to this group? So I can actually say groups cybersec to see the group this user belongs to. So I can do this for all the users, or I can just say getEnt group, and as you can see, we have dev team here, and you can see all the users that have been added to this group. So these are the ways you can actually confirm. And step 4, what's step 4? What's our next step? So if you're wondering why I'm actually using why I'm using the dash shell, is because I feel like the dash shell is going to reinforce your Linux command knowledge. For instance, some of all these things I've actually done them before. Using my normal Z shell, and if I was using Z shell, if I'm trying to like type a command I've typed before, if I don't clear up my history, you're going to see the terminal, like you're going to see the suggestion on the terminal, and I don't want to do that, because then it will be like pretty easy. I just like this because I have to type out everything, so it just reinforces what I know. I don't have to use auto completion like shell or environment. I just like this, because it reinforces everything. So we've added users to group. Now what we need to do is we need to change group ownership. At this point is actually CyberCat that owns this group. um, Mobile app is actually CyberCat group that owns this directory, so we need to change ownership. Change group dev team desktop mobile app. Okay, I think I've seen my bad. I was not supposed to spell that in full. Desktop mobile app. Okay, sudo change group dev team desktop mobile app. Okay, so that worked. Let's confirm it. Desktop. So as you can see, the group ownership for this directory mobile app has actually been changed. Now it's dev team that actually owns mobile app. So we can actually go ahead to like tweak this, but it's actually the way I want it to be. What's it called? Others can only read and execute when it comes like with regards to this directory called mobile app. Just for the sake of demonstration, um, for the user CyberCat, let's just change some of the permissions that CyberCat have in respect to this mobile app directory. So what are we going to change now? So let me take away. I'm going to take away. I'm going to take away the right access of CyberCat. That's what I'm going to do. So what you want to do is say change mode, right access. So read is 4, write is 2, execute is 1. So change mode, have execute, which is 1, don't be able to write, which is 2. So 5, change mode 5, leave group to be 7. You should have everything. And at this point, others and execute. So read is 4, execute is 1, which is 5. So 5. Then desktop mobile app. So let's see. Mobile app. So as you can see, CyberCat can CD into mobile app, can read the content of mobile app, but cannot add to the contents of mobile app. So let's try that. So cd desktop mobile app, present working directory, mobile app. So I can read the contents, ls, no errors. Let me see if I can add. I don't have write access, so I shouldn't be able to add. Yes, permission denied because CyberCat does not have write access. So I'm just going to set everything back to the default. So but I need you to understand that I don't want to start like switching users to show you what all the users can do based on the access I've given them. For instance, cybersec, dev and pro, which are the personnel who are supposed to work on this mobile app, project, they all have access to this, like they have full access to this directory. you know they can read, write, and execute in this directory. But OT, that is not part of that dev team, write to this cannot write to this directory. OT can read in the directory, which is ls. OT can cd into the directory, which is execute, in the case of a directory. So but if we want, we can also make it that OT won't even be able to get into the directory in the first place. So we can actually take his what's it called his execute access. And normally the way it works is, if you take away his execute access, it also removes his read and write access, because for you to be able to read and write to this directory, you should be able to execute, like cd into it. So I hope you actually understand what role-based access control is using this demonstration. So what I'll do is, I'm going to set the directory permissions, access permission, the directory access permission. I'm going to set it back to default, change mode. So initially it was full access for CyberCat and full access for dev team. So change mode 775, desktop, mobile app. Change mode 775, desktop, mobile app. Oh, okay. So I was just supposed to do change mode 775. I was supposed to do 775, then mobile app. Okay, so I've set everything back to default. So in a nutshell, in a very simple but comprehensive way, this is how you implement role-based access control. You want to put all the intended users in a group. Let's assume that we have like directories that only finance personnel should be able to access. What I'll do is, I'm going to create a finance group, and I'm going to add all the personnel in that group, and I'm going to change ownership of the finance directory. Then it's going to enable all the finance users to be able to access that directory. When they log into the system and they log in as a finance personnel, automatically they inherit the access permission of the finance directory. When it comes to people working in finance, everybody working in finance that have been added to the group that owns the finance directory will be able to access the finance directory. So I hope this demonstration was actually worth it. Do well to reach out to me if you have like any other question. I'm sorry, I know the video is kind of boring. No sound effects, no nice write-ups and animation, but that's not the purpose of this recording. Purpose of this recording is to show you my understanding of role-based access control and access control in general. So thank you guys for checking out this video, this project, which is also part of my portfolio. I'm going to see you in the next one.